From the EPAWA headquarters in South Allentown, Pennsylvania, it's time for Weather Weeklies, an informative video of the ins and outs of weather that affect you most in the EPAWA coverage area. The following segment is a weekly video blog, and the opinions of the forecaster do not necessarily reflect the opinions of the staff of Eastern PA Weather Authority LLC as a whole, nor its constituents. Without further ado, here is meteorologist Bobby Martrich with Weather Weeklies.
And good Sunday morning to you. Another edition of Weather Weeklies for Sunday, November 29th, 2015. We're going to dive right into the long-range forecast table here because we just updated this last night, and some of you saw it, some of you may not have. But this is our current projection for the long range here. We did make one adjustment here in the shortest range here. That's from the 29th to the 30th, and also for the first week of December. We actually went near normal as opposed to below. We actually originally had below normal from the end of November through about the 2nd or 3rd of December. That's no longer going to happen. Reason for that is because the system that's going to be affecting us right here, this is going to be Tuesday and the first half of Wednesday, is going to be bringing rain to the region, and that's because it's cutting to our west. Okay, that system cutting to our west was not originally projected to cut to the west. So by cutting to the west, it brings in some warm air advection, and several days of warm air advection out ahead of it will keep temperatures near normal 29th and 30th. But I do think as we get into the first week of December, we're going to stay above average. Not anything crazy above average. We will be above average nonetheless. Okay, so that cold end to November that was actually modeled for a while is actually not going to happen. We're actually looking at the next cold shot to come in the 8th through the 16th with slightly below average temperatures during that period. This is a big change from what you may have heard, may have read. If you look at the Climate Prediction Center from the National Weather Service or NOAA, they have their outlook out for pretty much the entire month of December. They have above average. And now we have December as a whole is near to slightly above average, not nearly as warm as they have it. But we do have this period, the 8th to the 16th, slightly below average. And then we'll have to keep an eye on what happens after that period because it can kind of go in two different directions. So right now we're kind of keeping it right to the 16th, and that's it, and not going any further because it's kind of like a flip a coin after that point. So we'll stick to this period here. And the reason why we have slightly below average we'll get into also because most outlooks do not. They have a very warm second week of December. If you look at the model guidance, it shows a very warm second week of December. So you're probably looking at us like we're crazy here. Why do you have slightly below average if all the models, all of them, are showing above normal temperatures? It doesn't make any sense. Well, it does, and I'll show you. So we also have a storm threat the 7th to the 9th time frame. It's too early to tell how much cold air will be involved with that system. So according to current guidance, it's showing it as a warmer system. But again, if our ideas are coming around to this colder solution, we might have to watch this system. It might not be just a rain system, or it might be partially wintry and going over to rain. We'll have to check and see how that works out with our temperatures first before we can dive into the storm threat. But there will be a storm in this time frame, whether there's white, a combination thereof, or wet. We'll have to wait and see until we get a little bit closer. Today, of course, is on the 29th, so we have some time to look at it. And then we have temperatures near to slightly above average for the entire month of December as a whole, and near to slightly above average snowfall for the entire month of December as a whole. We are sticking to that. We have not changed that and kept that at moderate confidence. Okay, now we're going to get into something a little bit different here. Take a different path here. Let's look at the tropical Pacific here. Here's Australia. Okay, what we're looking for is Tahiti. Now here's Hawaii right here. Tahiti is just south. It's south of the equator, but Tahiti is right down here, down south of Hawaii, well south of Hawaii. We're looking at the pressures over Tahiti and see that the pressures are low. All right. Now I just wanted to just so you can see what I'm going to get into what this means in a second. What I want to get into before I do this is the reason why I'm showing you this. When we do long range forecasting, we don't use the model guidance as a first resort. Okay? Again, we had that second week of December. Still, we have it slightly below average temperatures. If you look at the GFS ensembles, you look at the European model ensembles, you look at the Canadian model ensembles, and they're showing a warmer second week of December. So that's all of them. I mean, so if you're looking at that, you know, well, what are these guys looking at? Clearly, that's wrong, you would think. But see, in meteorology, you're looking at things that are not model-based. And I'll give you a perfect example, okay? I know a lot of you are football fans. Even if you're not, you'll understand this correlation. I'll make it very simple for you. Philadelphia Eagles played the Detroit Lions on Thanksgiving Day. It was 12:30 was the start of the game. Okay? If you came to me at 10 o'clock that morning and said, Bobby, I think that the Detroit Lions are going to win, and they're going to win big. Okay? You have no way of knowing that for sure. Let's just say you had one of these supercomputers, okay, that will analyze the offense, every player's defense, their strengths, their weaknesses. They'll do the matchups against, head-to-head. They'll factor in things like the weather, time of the year, injuries on each team has, and the supercomputer will come up with a prediction and say, okay, Detroit's going to win this game. All right, that's what the supercomputer projects. That is no different from what our models do. When we talk about model guidance, the GFS, the European model, Canadian, they are all projections. They are all assimilations. They take current data, current observed data, gets integrated into these models. Okay, each one has their own separate algorithm. Will take that information and extrapolate it out in the future, and it will predict the future. That's what this computer is doing. It's a projection. Now, the Detroit Lions did, in fact, beat the Philadelphia Eagles pretty handily, 45-14. Okay, so now if you came to me that afternoon at about 4:30, when the Dallas Cowboys game was coming on, okay, Eagles game has already ended. If you came to me and said, Bobby, the Detroit Lions beat the Philadelphia Eagles 45-14, that's not a projection. That is observed factual data. Okay? So, when we're talking about weather and long-range forecasting, when you're talking about observed factual data, that is indisputable evidence. That is indisputable. Nobody can say to me, well, no, the Eagles didn't lose that game. Well, you're full of crap, because I watched the game, and it's published everywhere. And it happened. It's factual data. This is not disputable. Same thing with observed data here that we're looking at worldwide. This is observed data, okay? So this is the Tahiti. We're looking at Tahiti here. This is the pressure falls over Tahiti. When we see the pressures fall over Tahiti, this is literally an if A then B, and then if A and B then C type situation. If you remember back to back to those equations you did back in high school. This is actual observed data. This is not a model projection. So the pressures we saw drop over Tahiti. What that does is it makes the Southern Oscillation Index, it will make it drop. And I'll get into what all this is in a minute. I just want to show you for argument's sake here. Here's from the 23rd to the 28th of November. Okay, this is the pressure drops that we've seen. And look what it is. It went from a positive number on the 23rd and has been steadily declining, and steadily declining. Now at minus 22.80. So we're seeing a rapid decline in the Southern Oscillation Index. Okay, what does the Southern Oscillation Index do? That promotes amplification in the ridge, or amplification in the jet stream. I'm sorry. Okay, so instead of what does that mean? Instead of having a fast zonal flow west to east with the jet stream really fast, bringing mild Pacific air, you have a chance of amplification in the jet. So that means you have big ridges and deep troughs. Deep troughs is really cold air. Big ridges is really warm air. So you have extremes. You don't have temperatures hovering around within a few degrees of normal like we have this week. Okay? Now, this is observed data. This is not made up. This is not a model projection. This is measuring the pressures. Okay? That's all this is. The Southern Oscillation Index is a measure of the pressures in relation to normal. Okay? Here is the Madden-Julian oscillation. Again, more observed data. This is the things we can see, the things going on right now. Southern Oscillation Index, by tanking and going severely negative, like we're seeing here, promotes convection around the international date line. Okay, here's the international. This is looking at the entire world on a flat piece of paper. We are right here. Okay, and it's hard to see. Here's the west coast of the United States. Here's Central America, South America. Okay, see where I'm going here? This is not a very good outline drawing here, but you get the idea. That's the Americas right here. The equator Comes right across like this. So the Baden-Julian oscillation is a measure of the convection along the equator in relation to the international date line, and it moves all the way across westward in the Indian Ocean. Here's the international date line, 180 degrees, okay? Look where all the convection is right now. Convection is right around the international date line. That's what the SOI promotes. When you're looking at the SOI, that's what it promotes. Okay? Convection around the date line. Why is that important? It's very important, okay? If you have a convection right around this area, that's going to throw heights at the western U.S. ridge. Okay? This is known as, this is an MJO phase 8-1-ish right here. This is a phase 8 or phase 1. Okay? That promotes a ridge out west in the western United States. If you have a ridge out here, you have a trough in the east. Okay? Now, this doesn't happen right away. It has a little bit of a lag time. So we'll talk about an 8 to 10 day lag time. So by the time we get to the 7th, that's when we think we change. That has a lag time of 8 to 10 days from the time the SOI tanks, and in response, the Baden-Julian oscillation gets to throw heights at the western ridge, pumps up that ridge out west here, gets rid of that positive EPO that we got going on right now, and moves that low from westward into the Aleutians, where we need it to be. Okay? Right now, this is what we're looking at. This is the month that this is what we're looking at right now. We have a positive EPO, and you can see that right here. This is a positive EPO bringing all this warm air here in the eastern half of the United States. That's what's going on right now. Okay, this is a phase 4 look, and that's what the models are showing of what phase 4 is. But if we get this is telling us different. It's not good. Models are all projecting phase 4. Well, this isn't going to be a phase 4. It's going to be a phase 1. And you can see that here. Here's the convection already responding to the Southern Oscillation Index tanking. And that was in response to Tahiti being having the lower pressures. So this is all observed data. This is all telling us that this is if A, B, and C are occurring. So this is what's going to happen. And we're eventually going to get into this pattern here by the time we get to phase the second week and maybe be the second half of December. Hopefully. What happens is instead of this low being over eastern Alaska here, it's forced west out here. Okay, your ridge ends up out here, and you get the trough in the east here. Then, okay, it's a big difference. Your ridge is then forced westward. You don't have a positive EPO anymore. Your ridge is then forced westward into Canada. Instead of being bottled up over eastern Canada here, is now forced out this way, and then the cold air is able to filter in underneath of it. So that's what we're looking for the week 2, and this is what observed data is telling us. This is not a projection, not a model projection. If I'm looking at the models in week 2, it looks like this, and it's ugly. Very fast zonal west-east pattern. Nothing exciting. Maybe a little bit warmer than normal, a couple days maybe slightly below. That's it. All right. So this is what the models are showing in week 2. But they're starting to indicate maybe we get some increased heights along the west coast here, but it's not responding downwind here in the east here yet. But I think it will as we get a little bit closer. Models are a little difficult and a little stubborn to move, but I think they will. They've been trending that direction. They just haven't gotten there yet. So again, we want the models to show what we're seeing from an atmospheric physics standpoint that should be happening. And the models, I think, will respond. It's just taking them a long time to do it, and they're a little bit stubborn when it comes to making changes. Okay, so that's that. I just want to go over that, why we're going colder than average in week 2, and that's the reason. We're just using things. These are things you learn in college. This is not something that you could just look at a model as a hobbyist and say, oh, well, this model saying this, and well, that's why you're going to be wrong, and that's why a lot of these outlets are being wrong are wrong also. We kind of go in a little bit different direction. We kind of know what we're looking at as far as looking deeper into things. Okay, now here's what we're looking at the last week as far as sea surface temperatures, and this is the El Niño, of course. Here's the difference between last week and this week, and you got a big increase here in Niño 3, especially 3.4. Niño 3.4 is now the warmest region, and that continues to show that from the latest data we're looking at. And you're like, oh, well, Niño 1 and 2 went up. Yeah, it went up slightly. Whoop-de-doo, your biggest warming is over here. I don't care. This can still go up. It's going to fluctuate. As long as this isn't the greatest warming area, and it's out here, this is ideal. This is ideal. So when we get into winter, get deep into winter, we're going to see that change here, especially when we get into January, February. I think this month is going to be kind of like a transition month here. It's going to start off warm, then we're going to transition to the cold, and we're going to get second half of December, probably have some up and down periods yet, and then we get into January, February, it's game on. Okay, and that's what happened here. 2002, you see the basin-wide El Niño event, very strong El Niño event, positive PDO as well. So we're looking at 2002 being a possibility as one of rain logs still. So we'll just have to keep an eye on that and see how that goes. I don't want to spend too much time on the El Niño because that's what we've been doing lately. It's talking about El Niño. I really want to get into this whole concept of the observed data and what we're looking at. Just from an atmospheric physics standpoint and the laws of physics. Everything has to follow the laws of physics, and I just wanted to point that out when we look at observations, not models, when it comes to long-range forecasting. We do look at models as a secondary thing. Okay, don't get me wrong, we still look at the models just to see if it agrees with what our concepts are saying, of what we're coming up with these physics principles. We're seeing if the models are responding, but I can tell you right now that based on what's going on observationally right now, this is not happening. This is the GEFS, the GFS ensembles, and that is impossible. That is impossible. So we will see what happens week 2 here, but we think the models are going to eventually come around to our idea of a pattern more conducive to slightly below normal temperatures the second week of December. Of course, you can follow this on not wait for our weekly updates. You can get this every single day in the EPAWA Premium Forum. We discuss this in detail with the long-range discussions, and these are updated by meteorologist Mike DeFino every day. Of course, I do a recap here on Sundays. That's all done publicly. We have that public update just once a week. So if you want the really detailed stuff where you can interact, ask questions with the meteorologist, join our EPAWA weather forum or premium weather forum. You can do that by clicking on the My Pocket Meteorologist image below this video, and you can join the many who have already subscribed and will be there throughout the winter. You also get first dibs at snow maps, and of course you can ask questions of our meteorologists instead of just waiting until maps and discussions come out. We actually get those in advance to our forum members, so please do check that out. Now, again, just click on the link below the image below this video, and I'll take you right to it, and you can become a premium member at that time. I'm Eastern PA Weather Authority meteorologist Bobby Martrich, and that is this edition of Weather Weeklies for November 29, 2015. See you again next Sunday.